Hey, Honors Chemistry, this is the beginning of our next unit, which is Unit 6, Particles with Internal Structure. So let us think about our model of matter so far. After Unit 5, what do we now know about matter? Well, we're in semester 2, and here's our model of matter so far. We know that matter is made up of atoms that are the base or particles of elements, and atoms of different elements can combine to form new substances. I want you to make a new notebook entry and record this in your notebook. We're in semester 2 now. And so we know that there's conservation of matter, and we'll keep that in. And we know we draw particles as circles, and we could draw bigger or smaller particles. We could have elements or atoms and compounds or molecules. Great. But we've added something in the beginning of this semester to our model of matter so far, and that is molar mass of an element. So make sure you include this in your new notebook entry on the model so far. I would add this. I would call this semester 2 model so far. And so we have matter is made up of atoms. Atoms of different elements can combine to form new substances. They combine in certain mole ratios. And we figured that out by getting the grams and then getting the mass moles of each element. And the molar mass of an element compound is the mass of 1 mole of the atoms or molecules. The mass of 6.022 times 10 to the 23rd atoms or molecules is the molar mass, and the mass of 1 mole of an element is found on the periodic table. So this is what we are adding to our model so far. This is where we are at. So I want you, if you need to pause the video and record this, you could do that. I'm going to continue going on. So I want to remind us of something that we learned about in Unit 4, which was thinking about how we separated water into hydrogen and oxygen. So I'm going to play this little video, and I want you to record some observations.
That small plastic container are two metal push pins, and they're inserted a distance that's between the positive and negative lead of the 9-volt battery. So you just insert them in there and make sure that they're that distance apart, and that should be fine. In the container is going to be some water that has baking soda mixed into it. Baking soda in the water allows electricity to flow between the two metal tips of the push pins. And so now you set them on the leads, and the electricity can flow between the two push pins now. And so electricity is flowing through the water, and so that's enough energy to break apart the water, make it undergo chemical reaction, so that the H2O gets broken apart into H2 and O2. It's going to be hydrogen gas and oxygen gas. And both gases are going to flow up through the test tubes. And one of the gases is going to be in one test tube, and the other one's going to be in the other one. How do you know which one's which? Well, if you take a look at the amount of gas in each test tube, it's going to be twice as much hydrogen gas as oxygen gas. So you can see in the right test tube, twice as much hydrogen gas as oxygen gas. This is how experimenters first learned that the ratio of hydrogen atoms to oxygen atoms in water is 2 to 1. It's 2 to 1 ratio. That's H2O. Now, there's another way you can show water undergoing electrolysis. You can take the same 9-volt battery, hook up two wires to it, and then the end of the two wires, you attach either brass wires or copper wires. It matters too much. Then you put the two wires into a solution of bromothymol blue, and bromothymol blue solution is also some salt, so you get the electricity flowing through the water much easier. And you can see electricity is flowing between the two wires, and you have bubbles forming. So that's the oxygen and hydrogen gas forming. Now, one of the leads is going to produce a different color. It's going to be a chemical reaction happening. So the yellow color indicates that hydrogen ions are being produced, and that's becoming more acidic. Bromothymol blue solution turns to yellowish and green when there's a higher amount of acid, more hydrogen. So again, this indicates that there's two different chemicals made, hydrogen and oxygen gas.
All right, and so how do we separate water into hydrogen and oxygen? We used electrolysis. And so make sure you write that in your notebook, especially with the observations from the video, that when you apply electricity, you're able to separate water into hydrogen and oxygen. But something is in that electricity that is causing the water to split into hydrogen and oxygen. There's got to be something that is allowing the water to go to the electricity and then all of a sudden split into hydrogen and oxygen, which leaves us to our next question. Would our model of matter be able to explain attractions? What is causing this water to kind of go to the electricity and split into hydrogen and oxygen? So we're going to need to do a little bit of investigation, which is what you're going to be doing soon. So new notebook entry, this is going to be called Sticky Tape Lab. Question, how do we explain the attraction of particles? So write that in your notebook. And at any point in time, you could pause if I'm going too fast here. So there's going to be a demonstration, and I have videos on this. You're going to use your desk tables. You're going to put some tape down, and you're going to have a base, a top, and a bottom tape. And what you'll see in the video is you are going to rip the piece of tape, cause something to happen to the tape, and then see how the tape interacts with itself and other matter. So F stands for foil, P stands for paper, T is top tape, B is bottom tape. And so there is a top tape and bottom tape that you are using. And so you're going to do something with them, and you're going to have them on the edge of a table. You're going to watch my video. That's going to be after this. And so how can interactions occur? Well, it could be top tape to top tape, bottom tape to bottom tape. Make sure you're writing this down in your notebook. Tape versus foil. So I could see how the tape interacts with foil. I could see how foil interacts with foil. I could see how tape interacts with tape. And I can also get paper interacting with paper. It's not written here, but paper interacting with paper. And there are going to be three different types of interactions. Either I'm going to have attractions, A, repulsions, R, or nothing is happening. I don't see an attraction or a repulsion. An attraction is going to happen if the two pieces come together. A repulsion is going to happen if they go away from each other. And nothing happens if nothing moves. You're going to also record this data table in your notebook. You're going to see, or you're going to perform all these different trials. You're going to see top tape with top tape, and you're going to write in the cross section of the box what happens. Does the top tape and top tape attract, repel, or nothing? Top and bottom, top and foil, paper and top. And a lot of these repeat. Top and bottom is the same. Bottom and bottom is different. Bottom and foil, bottom and paper. Foil and top, already got. Foil and bottom, foil and foil, foil and paper. Paper and top, already got. Paper and bottom, you're all you have. Paper and foil, paper and paper. So you're going to have people getting into groups, or you're going to observe and watch in my video somebody set up, being myself, the three strips of tape, paper, and foil. So your next step now is going to make sure that you have this table in your notebook, and you're going to observe the different types of interactions of top, bottom, foil, and paper with each other. And we're going to come to some conclusions with that. So your next step is to watch my video on how to set up and the observations for the Sticky Tape Lab.